as I always do before we go to a system of the body, I like to kind of give you an overview, because what's going to happen is we're going to swim down this chapter together and we're going to get lost in terms and words and things like that. But those words were made up by people like me just so they'd have jobs, right? What's really much more important is that you understand the concept of the digestive system and how a massage might affect it. It is not an incorrect statement. In fact, I think it is highly, highly true. It's not me just simplifying the information. It really is true. For you to realize that your digestive system is a tube that starts here and ends at your butt. It really, really is. And that tube might widen out in areas, and we call that your stomach, but that's the same tube. So you chew through your mouth, right? And the purpose of chewing is twofold. One is to break up food and increase its surface area. It's really hard to imagine, but if I take this ball here and cut it in half, it actually increases the amount of surface area that's available. If I cut it 10 more times, all of a sudden it's got more and more surface area, and the more surface area it has, the easier it is to break down. One of the ways you could think about this is if I dropped a sugar cube into your tea, it would take a lot longer for that sugar cube to dissolve than if I put a teaspoon of sugar granules in your tea, if that makes sense. Because when you put a cube in there, the tea has to eat away the sugar on the outside before it can get to the inside. When you put the granules in there, it just gets to hit them all at once. That's surface area. And I'm making a big deal out of this because many systems in your body work based on increasing surface area. It's quite impressive. And your digestive system is one of them. Your digestive system wants to increase the surface area of your food and then to run it through a lining that has increased surface area as well to help absorb that food. So we start chewing this thing to break it down into a whole bunch of little parts, right? And the second thing we're doing in our mouth besides breaking it down and increasing surface area is we are wrapping it in saliva. And saliva is very significant because it contains lots of enzymes, and enzymes are things that help chemical reactions happen at a lower threshold of energy, really. But anyway, enzymes help break down your food. And your saliva is full of them. And by the way, just if you guys want to know a nice little gross fact, you all produce about 1.5 liters of saliva a day. You swallow it, but you make in your mouth, it's disgusting. Yeah, 1.5 liters. That's like 4 full soda cans of saliva that you are just like gulping every day. And yes, Mr. Riedel.
Do people that chew gum produce more saliva?
They probably do, sir, because the chewing fact, I mean, like, I don't know the studies on it, but the act of chewing does create more saliva. So, yeah, if you've been chewing, especially Orbit, if you chew Orbit gum, it usually doubles your saliva output. That's true. If you chew Orbit on a motorcycle, triples your output. But yeah, sir, it does. The act of chewing does increase saliva. Ms. Trotter, please.
Do some people create more saliva than others?
Sure, and some people actually have a problem. It doesn't matter if you create too much in general. I mean, I guess you could drown in your own saliva. I've never heard about that. But the point is, the real problem is when you don't produce enough. There's lots of problems with that. When you don't, because part of what saliva does too is keep a certain environment in your mouth. And if your mouth gets really dry and doesn't have enough saliva, your gums go bad. And when your gums go bad, you lose your teeth. And then you don't have saliva to digest food too, which doesn't mean you don't digest food, but it means it's much harder on your digestive system to digest food. So yes, lack of saliva is a bigger problem than this gross fact that you just learned that you guys are all producing like one of those big 2-liter bottles of soda. It's 3/4 full and you're chugging that down with your own saliva every day. Okay, anyway, so we're increasing the surface area. We're surrounding this stuff in saliva, and then we swallow it back through our throat, and we kind of go into this area called, by the way, we're going to go over a whole slideshow. This is just like my big, speech, because I think it helps give you places to put the information when we come across it. So it's going to go through this area in the back of your throat here, basically, where your trachea, your windpipe, and your esophagus are right next to each other. And then a beautiful little flap will come down to cover your windpipe and make sure the food, which we now call a bolus, because it's all ground up and whatever, and it goes down your esophagus. And that's where that tube starts, right? And the esophagus widens at a certain point and becomes your stomach, but it's the same tube. It widens. And your stomach is full of acid. Your stomach is lined with mucus. By the way, a lot of the stuff that we think is gross up here in our nose and stuff is saving our lives. Because if your stomach wasn't lined with mucus, the acid in your stomach is stronger than battery acid. And it would burn through your own stomach and kill you. So it's kind of what an ulcer is, right? It's when the acid is starting to burn through your stomach and there's some bleeding going on in there. That stomach, by the way, all this tube is wrapped in smooth muscle, especially that stomach, because the stomach, when it gets down there, starts literally squeezing and churning and moving that food around, and it's pretty big. And your stomach, by the way, can hold, some people's stomachs can hold 4 liters. But anyway, 2 to 4 liters. So the 2-liter soda bottle, your stomach can hold that much food easily. Some people can double it. If they've been practicing, you can literally stretch your stomach. Anyway, it gets down there, it's churning that food around. This acid is doing 2 things that are really wonderful too. One of the wonderful things it's doing is breaking the food down further. The other wonderful thing it's doing is this acid is pretty good at killing just about everything, and that includes bacteria, viruses, everything. So this is your body's chance to make sure, before it lets stuff really kind of get into your body, I realize it's in your body, but before it lets it out into the cell areas of your body, that it kills off a lot of stuff. Yes, Mr. Blygen, please.
I don't know if you know the answer, but when someone dies and they're getting like nice, all the stuff taken out, how do they get rid of the stomach acid? Or does it kind of fall out of them when they die or something? I don't know.
I was about to scold you and say I dislike your lack of confidence in my inability to answer this question, but then I heard the question and I have no idea. And what's weird is I used to date a mortician. And she wasn't a mortician, but she did the embalming. She's a sweet girl, and she did the embalming, and she never told me about the stomach thing. She told me about how they take the long tube to get all your blood out of your body and fill it up, but she never mentioned the stomach thing. So I don't know. That's where that leaves us.
Yeah, that's what, I don't know, I just thought about that randomly.
Yeah.
Because I know embalming fluid, I don't know what that does, I just know that that's a thing.
Well, they use it to empty out all the blood out of your body and put a preservative in. They're kind of pickling you in a way. My concern with, I do know that bodies can kind of blow up if you leave them alone too long, and the stomach acid and everything in there can get in there and build up gases and stuff. So I'm assuming it might slowly eat through your stomach and kind of build up acids inside the body and such if you didn't get to it in time and you left it out in warm weather for a while. But this is kind of getting more into forensics and out of massage. Yeah. Good question. I have no good answer. Yeah, thank you. Anyway, so they get down the stomach, they're churning all this stuff around, and then you've done a pretty good job breaking stuff down into small parts. The acid in your stomach is killed off, hopefully all the bacteria. It's going to release this stuff into your small intestine, which is the squiggly wiggly tube, right? Same tube, by the way. Stomach goes back down, changes into the small intestine, but it's still a tube. Squiggly wiggly tube, and even though it's called the small intestine, it's smaller around, but it's actually quite long. And that is where your major absorption takes place, and your body uses surface area too here. In the small intestine, you've got all these ripples. If anybody's ever seen how a radiator works on a car based on surface area too. It's got all these ripples running through it to increase its surface area to dispel heat. These ripples have blood vessels in them, and there's so many of them that the food can kind of seep through the intestines and get into the bloodstream. And then your cardiovascular system carries those wonderful nutrients around all your cells. After it's done going through the small intestine, it pops into the large intestine. At this point, most of your digestion has been done. The large intestine does pick up a few things like vitamin K and some strange things. And if you are lactose intolerant, you have bacteria in your large intestine that can digest lactose. it just doesn't do a very good job, and it produces a tremendous amount of gas and discomfort, which is why if you're lactose intolerant, you would notice that more when it got to your large intestine. And the large intestine is actually quite short. It's a little final victory lap before you go to the bathroom. And really, probably the main purpose of the large intestine is to extract extra water out of your bolus or your fecal material before you poop it out. And yes, you all poop. Because water loss is actually a really big deal, right? I mean, we didn't used to always have water on tap, and so you do not want to lose a pint of water every time you go to the bathroom. So really, one of the things that your large intestine does is pick up extra water and get it back into your body, and then you go to the bathroom. In fact, if you're having a hard time going to the bathroom, one of the first things you should look into is dehydration. Because if your body is low on water too, it'll pull it out of your large intestine, because that's one of the places it goes looking for it, and that will make you constipated. So, anyway, and then what happens is you have two valves in your rectum. One is not under your control, which is good. Your brain keeps it shut, so especially while you're sleeping, so you don't poop yourself when you're sleeping, because you would. Yes, you would, especially you two. You know who you are. And then once your brain releases that valve, you have a choice of control on the final valve, which is when you have sensors that go up to your brain and say, I really feel like I have to go to the bathroom. And then you do, hopefully, right, in the appropriate place. And that's it. That's what happens. That's how your digestive system works. Yes, Mr. Blygen?
Do you have a thing back there that you can just point and show us what you were just saying? One of those
models? I probably do. I don't know if it's going to show you really well, but I will do that too, sir. And I also have a slideshow with all this on here. It's got a whole bunch of slides. Let's do the slideshow. If it doesn't satisfy, we'll take a look at the model. We do have like a little half-body model that might kind of show you some of that. Yeah. Miss McDowell, yes.
So you were talking about a flap earlier. Where does the distinction for like when you drink water, it doesn't go through your digestive system? Is there like a flap there that opens that goes to your kidneys and your urinary tract?
Water goes through your digestive system.
Oh, it does?
Yeah.
I've been misled.
You have been, with all due respect, and I'm no expert on systems of the body. I'm expert on muscles, but no. You've got two tubes, and it either goes in your lungs or it goes into your stomach.
Well, that's where it must be.
Yeah. If the water's going into your stomach. That's cute. So you thought there was a little extra tube that went down to your kidneys. That's
I don't know. I thought like there was like another like tube there. It was maybe like behind it and hidden.
Yeah. We had this whole class where we talked to the students about things that you should know as an adult but somehow got missed along the way, and everybody has a story about something like this where they're like, I always thought it was this way because somebody made a joke when I was 5 and I assumed it was true, and you don't realize till you're like 37 that it's not true, this thing. So anyway, it's not just you. We had a class on this, and like everybody in class had a story about like, I thought whatever, and really funny stories. Stuff that would be obvious, and they're like, now that I know it's obvious, but it wasn't at the time, yeah. But anyway, no ma'am, it's all. If it's liquid or solid, it's going in the esophagus, and if it doesn't, you're in trouble. It's going into your lungs.
So the whole time, like, it gets absorbed in the small intestine, like the same as the other liquid? Okay.
Yep.
Alright.
I mean, liquids probably pass out of the small intestine quicker, but it's going through the same tube and kind of going through the same process. And it's even helpful to the bolus. Your body wants to mix it into the stuff. Your body wants to get everything kind of soupy and wet until it extracts everything it needs from it and then dry it back out again. And so, yeah, water's a big key to that. But even if you just drank water at home, I mean, yeah, it's going through your digestive system like normal. Yes.
Well, that's good to know.
Yeah.
Thank you.
Good stuff. We're keeping it simple here, yeah. Miss Sarno, you had your hand up.
Yes, I have some friend. They have like the water flush inside the lung, and they have something issue inside the lung. They have to cut from right here to that and open up and take the water out.
But that's not from them drinking, right?
No.
I think they're getting fluid in the lung from a problem they have in their lungs.
Yes.
And by the way, it's super serious what she's talking about, everybody, because they'll drown in the fluid that fills up their own lungs, so they have to drain the fluid. But yes, that's from some type of lung infection or something. But yes, I understand, Ms. Serna. So yes. Cool. All right, everybody, let's take a look at the slideshow so that we can see if these pictures kind of make some of this a little bit better, better for you to understand. Okay. All right. Okay, so your digestive system. Your digestive system is essentially a disassembly line. Its whole job is to break food down. And I know this isn't quite true, but honestly, when you eat a hamburger, your body is kind of making those hamburgers into tiny microscopic hamburgers that your cells could eat. Now, I know they're not still hamburgers, and please, I'm not trying to talk to you like you're 3, but my point is, it's still like, it breaks it down into small chemical components. It's not magical. It really just keeps busting it up and busting it up and busting it up until it gets this food down into lipids, which are fats, carbohydrates, which are sugars, and proteins. And it breaks this stuff down into tiny, tiny things that your cells can then pick up and use as they need. So it really is just this process of making stuff really tiny. We do know, by the way, that you need to be in the parasympathetic state to digest well. And there are studies all over the place. Actually, since the beginning of time, this is one of the first things they discovered about the digestive system a long time ago. It's a long story, but a long time ago, a guy got shot, like in, 1800, something like that. He got shot, and he actually had a hole in his stomach, and they didn't seal it up, and they were able to kind of watch what happens to food when it goes in there. But one of the things they noticed, yes, I know it's crazy. It's really a true story. But anyway, one of the things they noticed was that when this person was stressed and stuff like that, their stomach stopped functioning. I would be stressed already if I had a hole in my stomach. But anyway, they lived for years like this. It's very interesting. So we know that massage helps put people in the parasympathetic state, which helps them digest, among other things. And that nervous system does not help you digest. That also means that massage might get people to start digesting on your table. So it is not crazy to have a client pass gas on your table or something like that. They're relaxing, and their digestive system is like, hey, good time to digest this food that's all running through me, and there's just lots going on. And they're relaxed too, so they might not notice. I'm just kind of warning you. Yes. Yeah. Anyway, because I've had that happen. Yes. From a sweet little old lady when I was working on her glutes. I thought I broke her sacrum or something because she made a popping noise. But it was not her sacrum breaking. It was her fart sounded like popping. And it was so cute. And I was like, oh my God, what did I do? And she goes, it's okay, dear. That was me. Very sweet lady. Anyway, that's my farting story for the day. True story. Anyway, okay. So today we're going to kind of learn about some of the anatomy of the digestive system, the oral cavity, which is just a fancy name for my mouth, and the pharynx, which is where my esophagus and my trachea come together, and the food has to decide to pick between one of those 2 pipes, not 3 pipes. There's no liquid pipe back there, just 2 pipes. And I'm just teasing you, ma'am. I hope it's okay. My esophagus, which is important. Remember, my esophagus, by the way, for massage therapists, this is important. Your esophagus is your food pipe. Your trachea is your wind pipe going to your lungs. My trachea is in front. My esophagus is behind, and they're both right here. Okay? It opens up in your stomach. We talked about your stomach. The acid and all that stuff goes into your small intestines. All the food gets absorbed, go into your large intestines. All the water gets picked back up again. And we're going to talk a little bit about the liver, which produces bile that's stored in the gallbladder, which helps you break up fats. Actually, it doesn't really help you break up fats. It's actually like a detergent and keeps your fats from coagulating together and getting too big so that the other enzymes can attack them. It keeps them small. It breaks them up like detergent. It really is like detergent. And we're going to talk about the pancreas a little bit too, that just produces a boatload of enzymes that help you digest all kinds of proteins and lipids and carbohydrates. Pancreas is really helpful in doing that. Cool. So, ingestion is taking materials into your mouth. These are just some definitions. I'm sure they will be on your test tonight or this weekend. You'll obviously have till Monday to do it. Digestion is the breaking down of those materials. And enzymes are catalysts in chemical reactions, but basically enzymes in this case help you break down food. So, yeah. Absorption is how you get that stuff. Once you've broken it all down, your body absorbs it. It literally absorbs it. When you get molecules small enough, they will float through your tissue. And your tissue will allow certain ones to come through or not and get picked up by your bloodstream. And your bloodstream is your transportation system for food in your body. It does a lot of other things, but that's one of the big things it does. And then defecation. Defecation is a nice way to say pooping. It's a longer way, but it's a better way, unless you like to say pooping. And I'm okay with that too. All right, moving right along. Mr. Blygen, this is a picture. I don't know if it's kind of want it, but it's a pretty good picture. It shows the oral cavity here, the salivary glands, which I was telling you these guys are working to produce the 1.5 liters of stuff, the pharynx, where your windpipe is here, your esophagus is back here, your esophagus goes behind the liver, and then here's the stomach down here. And then the stomach goes behind here and into the small intestine. It connects down here into the large intestine, goes around, goes out to the rectum, and finally out through the anus.
Yeah, the liver is a lot bigger than what I thought it was.
It's the largest internal organ you have. The largest organ you have is your integumentary system, your skin, but the largest internal organ you have is your liver. And it's an amazing detoxifying organ. Its main job, it does all sorts of other really cool stuff, but because like break down fat and stuff we're going to find out here, but its main job is it really cleanses a lot of the toxins that build up in your body. And yes, this is a standard size liver. If you drink a lot, they get bigger. If you drink a lot, they get bigger and fattier. If you drink a lot, they get bigger, fattier, and die. But they're also capable of repairing themselves quite effectively to the point where some people can have somebody else's half their liver put in their body and both livers will grow to full size again. So it's highly repairable tissue, thank goodness, which is very helpful too, not just like with a drinking example, but let's say you got poisoned or something. If you survived, even though it was really hard on the liver, your liver is very good at kind of coming back and repairing itself again after a really harsh attack of something. So yeah, it's good to know. You're absolutely right. It's huge.
So the liver and the kidneys always get confused as to what goes there. Like I know that they basically act as a filter, right? Or
they both act as a filter. We tend to associate the kidneys more with your bladder because they do a lot more of the water extraction, and then your kidneys they go directly to your bladder. Your liver filters a lot of the blood going through it. And when it comes to your digestive system, the liver actually doesn't directly connect to it. It creates bile that goes into your gallbladder, and your gallbladder literally squirts a little bit of bile, which is meant to break down fats, into your small intestine. Yeah. Cool. All right. Moving on, sir? Maybe? Okay. And this is in your book, by the way. As far as I know, this picture is in your book. That's this thing. Hopefully we've seen this thing. We've opened it a couple times. Good, okay. He's like, I have no idea what that is. Yeah, I know. All right. You're doing pretty good for somebody who doesn't know what that thing is. Okay. So, I already said this. The GI tract, the gastrointestinal tract, is really a muscular tube from your mouth to your anus. It does widen in areas, it narrows in areas, but it is a tube, a literal tube. You could take it out of somebody's body and you could stretch it out about 25 yards. It is a long tube. And the point of the tube is to give you a way to break stuff down and then absorb it into your body. Yeah. Let that go. Most of this tube has a inner layer called the mucosa, and it should sound like mucus because that's what it does. It forms snot. It forms snot because acid doesn't break down snot very well. Snot's pretty amazing. And you line your intestines with it for all sorts of reasons. One is you line your stomach with it so the acid won't go through there. But also it acts as a lubricant so the food doesn't get stuck in your body as it goes through. It's excellent. Excellent at doing that. And then, yes, Miss McDowell, please.
Is that the same mucus that people have like in their sinuses and like in their nose?
Yeah.
Or is it different?
What?
Is it the same or is it different?
It is the same.
How does it get up there?
What, up here?
Yeah, like
Oh.
this, like the mucus, because if it's made there, how does it get in your nose?
Oh, it's not, the question's not bad. It's just funny for some reason. Because you're like, well, how does it get there? Like, is it coming up through the thing and going up this thing? Mucus is made literally on site by mucous membrane. And you have mucous membranes all around the inside of your nose and inside your face.
Oh, okay.
And you've got mucous membranes. So this is just like your skin sweats. You've got this stuff that makes snot. And it's in your nose, it's down your throat. So the entire lining, it doesn't have to come from somewhere. It is there. It's being made there. Yeah.
Okay.
It's kind of a self-protective measure. The cells are like, we need to put this stuff out here so we don't get eaten alive. Up in your nose, one of the big points of the mucus line, it's still made by the membranes up here. One of the big points up here is to catch dust and stuff before it gets down to your body. It's kind of clever, actually. Yes.
Interesting. Okay.
It is interesting. Yeah. And I know it's a little bit gross, but it catches dust and stuff up here. And I know sometimes you feel mucus go down the back of your throat. That's going down your esophagus, which is good because it's your mucus. And the esophagus, it's going to dump all that, what could be foreign particles. It could even have, viruses and stuff like that. It's going to dump it in that acid in your stomach before it goes anywhere and kill it off. It's a good system. Then your body moves the food through, the bolus through, with something called peristalsis. So there's smooth muscle around all these tubes, starting from up here. And you can hang upside down and eat a meal and stay hanging upside down and digest the entire thing. I recommend you put yourself right side up again before you go to the bathroom, but you could. It will work, your body will work, and it will do this because, yes, Ms. Trotter, you're right. That's exactly right. The visual you got there. It does this because of peristalsis. And that is literally like the muscles go squeeze, 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 and they squeeze stuff through a tube, and it'll actually work against gravity. It'll work in any situation, and it's peristalsis. And you've probably even felt it internally without knowing what you were feeling, where you're like, oh, well, stuff's kind of moving around in me. That's peristalsis. Yeah. And it'll move stuff along. And you've got two different kinds actually in your large intestine, where your large intestine does little movements along, but sometimes your large intestine is like, let's clear out this section. You'll squeeze out a whole section of the muscle squeeze. And that's when you're like, I gotta go. I'll see you later. Yeah. Cool. Okay. Peristalsis. Beautiful. I don't know if I want to get into peritoneum now because it's not exactly the digestive system. The fact is you have large membranes in your abdominal cavity to help coat everything and cover everything and keep it from rubbing against everything else. That's all. We're not going to get into it right now. Okay. Here's a side view of your tummy, although it's not very important to us. We're moving on. I already said what the bolus was. A bolus is just a fancy name for a hunk of your chewed up, wet, slobbery food that's now going through your digestive tract. Yeah. And they like to call it a bolus. They don't just call this, by the way, in humans. We talk about it in animals too. You know, so some people that are, I don't know, park rangers and stuff, they study like animal boluses, like what comes out of them. It gives you a really good idea what they've been eating and things like that. Some of you might have found an owl bolus on a hike. Owls eat like mice and they digest them whole. And then there's just kind of the skeleton bolus comes out with some hair on it. I don't know how they do it, but it's amazing. And that's how you know it's an owl. You're like, this whole thing just came out like this. You do not, you will for your test tonight, but you will not need to know the particular enzymes that break down a particular thing, right? Where it just doesn't apply to massage. But you should know, you know, saliva is meant to kind of moisten your mouth, and it has lots of enzymes in it. It breaks down food. Amylase is an enzyme that's designed to break down carbohydrates. Carbohydrates are just complex sugars, by the way. Do we all know that? So, sugar's got a bad rap. Carbohydrates don't have as bad a rap usually. When you take a whole bunch of essentially table sugar and you link it together in long chemical chains, it becomes carbohydrates. And why carbohydrates are generally considered better than eating table sugar for you is your body has to break the carbohydrates apart one by one. So it'd be like you taking tiny, tiny bits of sugar all the time, which is good. You're not peaking or falling at all. You've got a long sustained energy. And so, whereas sugars tend to hit you all at once, right? And then your body has to convert that with insulin into fat because you don't need all the energy at once, all that kind of stuff. So carbohydrates are really just long chains of sugars that take longer for your body to break apart. Let's see. Let's move on. Let's move on. We don't need any of that. You won't care at all. We already told you this is behind the windpipe. Oh, your food does have to get through your diaphragm. Through the esophageal hiatus. Anybody ever heard the term where somebody says, I'm going on hiatus? Okay. It means leave. I'm going on leave, hiatus. Well, you've got some hiatuses in your body. And these are holes usually where the thing that was there isn't there anymore. And so one of the things that I have underneath my rib cage here is a diaphragm. And that diaphragm is underneath my entire rib cage, front to back. And when it contracts, I breathe in, and when it lets go, I breathe out. Well, you have to have a hole going through that for things like your esophagus to get down and your arteries and things like that. From stuff from the top of your body get down the bottom. And so there's a hole in your diaphragm called the esophageal hiatus. Occasionally people have problems with them, but it has nothing to do with massage therapy again anyway. You have these rugae folds in your stomach. Again, probably not the most important information to know, but the point of them is your stomach has the ability to expand and contract massively. If you've ever seen the guy that wins the hot dog eating contest, who always weighs like 113 pounds or something, and then he eats like 47 hot dogs. Anyway, he has developed over time, he's actually trained his stomach to stretch, and he's got these little folds in his stomach. We all do, but he's probably got more. And they're rugae, and they will unfold, and it allows his stomach to kind of get really big, and then it can fold back up a little bit. And then once it's all mixed in with the acid and stuff, some people call this chyme at this point. It's all this stuff mixed in with gastric juices and saliva and all this stuff. We're still in the stomach. And we're moving on down. Eventually we will go through the pyloric sphincter. But by the way, your whole digestive system has a whole bunch of these. This is a sphincter. It's a round muscle. But I've got one here. I've got one at the end of my stomach that's called the pyloric sphincter that decides that once your body realizes the food is chewed up enough in your stomach, it'll open that in small amounts and let it go into your small intestine. And of course, they name sections of your small intestine and all that kind of stuff. The first section is the duodenum, but it doesn't matter. It's your small intestine. The acid that your stomach is creating, it creates its own acid. It creates it there on site. The cells there create it there too, and it's hydrochloric acid. It is really, really strong stuff. It is much stronger than battery acid. It will eat through flesh. If you didn't have mucus down there, you'd be in big trouble. But it's really good at killing stuff too. Yes, Miss Lobitz. And are you okay?
Yeah.
She's like, I'm tired, my head hurts. Yes, ma'am.
So when we get food poisoning, is it because it's bacteria that our stomach acid couldn't kill, or there was just too much of it?
Yeah, that's my understanding exactly. So it's hydrochloric acid. It is good at killing stuff, but there's a couple of problems that can happen. If you get too much, and there are some, by the way, if you've heard of salmonella and what's the other one? Botulism. Those are terribly strong bacteria, and they do pretty good at fighting against the hydrochloric acid, which is shocking. And if there's enough of it, you hit the nail on the head. If there's enough of it, it might get through, and it's such a virulent, such a strong bacteria that if it does get through there, it makes you very, very sick. It's a bacterial infection. The other problem that can happen, if you don't don't let this freak you out, by the way. If you've got salmonella in your food, you're already in big trouble. But if you don't chew your food very well and big pieces come down into your stomach, if you think about it, the bacteria could be inside here. The hydrochloric acid will get all this stuff on the outside. It doesn't get everything on the inside. So the better you break down your food, the more likely the hydrochloric acid is to get in there. And that's the chewing effect too, right? So if I throw back what's really great for getting salmonella and botulism is lunch meat that they've had sitting out at some event for like 4 or 5 hours, right? It's been sitting out there and you don't chew it. You throw a couple of slices of lunch meat in your mouth because you're hungry and you run on by and they're loaded with one of those things and yeah, you get very sick. Yeah. Yeah. The cool thing is, by the way, sometimes your body catches this. If you have thrown up before, which I'm sure we all have probably at some point, that is your body thinking that there is something in your stomach specifically that it thinks is bad and it's caught on and it wants to get rid of it. So you might have experienced it from drinking too much alcohol, but there are times that you'll eat something that doesn't agree with you. And that really is your stomach being smart. And it's like, no, we are not sending this all the way through. It's coming back out. Of course, you can also throw up for emotional reasons. So when people get really scared or really nervous, sometimes they throw up. But again, that's your digestive system being linked to your emotional state. Did that answer your question, Ms. Lobitz? I realize I tangented off too, but okay. Okay, love it. Small intestine, 20 feet long. 20 feet long. It's in your tummy, right below your tummy. Yeah. This is where most of your food digestion takes place. Theoretically, your food has been pulverized by now, and it is a wet, soupy mess, and there's lots and lots and lots of capillaries, which are teeny, tiny little blood vessels that are kind of sitting on the small intestine, and it's so small that tiny molecules of your food can float into those blood vessels and get into the rest of your body. That's how it's supposed to work. That's how it's supposed to work. And they do name sections of your intestines. The duodenum is the first one, and that's where the bile from your liver that was stored in the gallbladder gets injected in there right at the start. And that's to help to act as a detergent to keep your fats broken apart so they can be more easily eaten up by enzymes. Why is it so difficult to digest fats, you ask? Because fats don't dissolve in water. What are you mostly made out of? Water. You guys are water babies. You really, really are. Adorable water babies, by the way. And fat does not dissolve well in water, and so you have this bile come in, and what it does is it acts like a detergent. Can't actually break down the fat, but it can keep it from coagulating together into bigger and bigger fat things. Keeps it all separated so enzymes can come in there and pick it up, because that fat's a great stuff. You need it, but that's why it's a challenge. And we'll get into pair patches in a second. Let's go a little farther. Okay, here's what's really important. Remember I said your whole digestion works on this concept of surface area? So we increase the food surface area, right? Well, the small intestine's job now is to give that food as much surface area as possible. And it's hard to kind of explain, but if I have a tube here, this is a regular tube, right? That's got a certain amount of surface area on it. But if I put little bumps on it like this, that dramatic, if I unstretch this thing, we can see that this would be much, much longer because it's ripply like this. So if you have something ripply, it's actually got more surface area. So that's not good enough for your body though. Those are called villi over there. Your body puts microvilli on the villi. So your body, instead of just making a straight tube, what it really did was make something that kind of looks like this. I hope you can see that this line would be a lot longer if I stretched out, but then it puts all these little bumps on that. So if I had to go around each one of these, it's even more surface area. And that's what villi and microvilli are used for. And this is where the blood vessels come in. Your blood vessels come in here, and they attach to all this stuff. So that when it picks up delicious food from up here, it eventually gets absorbed down into your bloodstream and circulated around your heart, by your heart, in your arteries, in your veins, and taken to all your cells so they can eat. Because what your cells can't do is go to the refrigerator. So the cell in my big toe can't leave my big toe. So the whole process of my digestive system is to actually break down food for my cells. In a way, it's not even really exactly doing it for me. It's doing it for all my cells that compose me. Right? It's a system meant to break down food. In fact, you guys don't really actually even fart. That's actually the bacteria in your intestines doing that. That's not you. You have all this healthy bacteria in your intestines that helps you digest food. Good bacteria. It helps break it down even further for you and eat it, and one of the things it produces is methane gas. And methane gas is that stinky gas that comes out of your body sometimes. But it's not you, so next time it happens, be like, I'm sorry, that's my bacteria. Yeah. Okay. That's villi, microvilli, just increasing surface area. Strangely enough, the inside of your small intestines would look and feel like velvet. Like all this just soft, like surface area everywhere. I know that's a weird thing to say about the inside of your intestines, but maybe not yours, but mine. Velvet, for sure. Okay. Are we doing on time? Okay, we're good. This is a good picture. This is a pretty good picture of the villi and microvilli, and if you can see the capillaries going up there to pick up the food that's going to slowly absorb through the tissue. Yep. Yay. I love it. Your lymphatic system, which we have not talked about yet, we haven't really talked about your circulatory system that much either. Your lymphatic system also kicks in here too, and your lymphatic system picks up a lot of the fats that are in your intestines, because fats are actually rather large and they have a hard time getting the capillaries. And so they're often picked up by your lymphatic system, which is another system of tubes that works with your circulatory system, and we will study it separately. Okay. This is not important. Lactase, yeah, maybe. Just be aware that a large part of the planet is actually genetically is lactose intolerant. They lack the enzyme to digest the sugar found in milk and cheese, therefore, and dairy products, therefore. In general, I am generalizing horribly, but it's true because of genetically where it comes from. In general, white people digest lactose pretty well and black people do not. And that's just a genetic thing. They just lack the enzyme to do so. And that, it would depend on who your parents are and all that kind of stuff. But we see that like in very Scandinavian populations, like 90% of them have this enzyme digest milk very, very well. And then we'll see in black populations where maybe 10% has that enzyme, and so they don't digest that enzyme as well. It won't kill you then to have dairy products, but what happens is the bacteria in your large intestine tries to digest it for you, and it creates lots of gas, bloating, pain, things like that. That's it with that little thing. Then this finally gets into, from the small intestine, we're done with that. We go to the large intestine, as I promised you we would. I know you're excited. And it goes from the small intestine to the large intestine at this another sphincter valve called the ileocecal valve, and heads down the large intestine, whose main job is to get out water and electrolytes. But electrolytes are really like minerals that are commonly found in water and such. And that's about it. Really is. You do have an ascending colon, a transverse colon, and a descending colon before it heads on out of your body. And so it really does go ascending, transverse, descending, rectum, and then anus. And rectum, I'm sorry to be so blunt, but it's like that's what it is. Your rectum is your holding tank for your poop when your body's like, you really need to do something about this. Once it's there, you have that strong urge to go to the bathroom. And you have very special sensors from your nervous system, by the way, down there that tell you very interesting things about your holding tank. They tell you how much pressure you feel in there. They tell you how much moisture you feel in there, so that you can make a determination if it's just gas or if it's actually something in there, right? It doesn't always work perfectly, but that's what it's supposed to do. And so you're able to actually sense what's going on inside your bottom, so you can make determinations about it. Yeah. That's it, really. Beautiful, beautiful picture here. We can see, by the way, the appendix here. The appendix is actually at the beginning of the large intestine. For a long time there, they said it had no purpose. They were just sure. There's now a lot of medical practitioners that theorize that it definitely has a purpose. One of the things they think it does is it's a bacterial storing location. And here's why you might want one of those. If you've ever been really, really sick, where it's coming out both ends, you are also blasting all the bacteria out of your body. And even though bacteria's gotten a bad rap, we're alive because of bacteria. Lots and lots of stuff is done in your body, very much like we talk about in this class, by the help of other things. And so billions and billions of bacteria actually help you digest your food, actually help you fight off other invaders because they want you to be healthy because they live in you. Like, you have a very good relationship in general with bacteria, in general, the right kinds. And you have a particular bacterial garden that is unique to you in your intestines, although it's fairly similar probably to your family, especially if you live with them. And they've done all these studies about this. So you pick up a lot of your family bacteria, which is good because it helps you eat the type of food your family eats. This is sometimes why when you go to a new diet, it kind of throws you off a little bit. And it's because you may not have the bacteria in your body to digest that particular food. Anyway, and by the way, we also think this bacteria is responsible for cravings. So if the bacteria likes pizza, it's very good at digesting pizza, it will actually make you crave pizza. That's not exactly the case, but it's really close. If this bacteria likes certain types of fats or whatever, it'll make you crave them because it wants them too. So there is a connection between your brain and your intestines. So anyway, if you are expelling all this because you're really sick, you want the good bacteria to repopulate, and they believe the appendix holds, it's a little storage bank of good bacteria in case something were to ever happen to really kind of empty you out. Because you really can empty out your large intestines. And I don't just mean like when you were sick. What I meant was if you were able to look inside your large intestine after having that type of illness, you'd see a clean large intestine. It really does clean out. Anyway, so that might be to repopulate that area. Yeah. That's it, except that we already talked about well, let's talk really quickly about the liver, gallbladder, and pancreas. For the digestive system, the liver does 100 things, but for the digestive system, the liver creates bile, which is a detergent to break down fat. It stores it in a little purse called the gallbladder. The gallbladder occasionally squeezes it into the small intestine. The pancreas is nearby, and it creates a whole bunch of enzymes to break down food. That's it. Really, really is true. So here's the liver. Here's the gallbladder. Those ducts that they're talking about are to inject the bile into your small intestine. You can see the pancreas nearby. It does the same thing. It injects enzymes in there to break down carbohydrates, fats, everything. Yes, Miss McDowell?
What's the spleen and what's it doing in there?
Spleen, he's just hanging out because he fits in there. That's just where the spleen is located. The spleen is not really a digestive thing. It's another blood filter. And it's kind of a neat thing, actually. Your spleen is really part of your lymphatic system, if you want to talk about it. It is a blood filter. It's got lots of white blood cells in it. Fights off infection, things like that. It also holds a pint of blood. And why that's significant is blood pressure is a really big deal. And yes, you don't want high blood pressure, but in some ways, what would be worse is if you cut yourself and you all of a sudden got low blood pressure. Since you're a pressurized system, if you lose pressure, you can't get blood down to that big toe. And so the spleen is there also to be an emergency blood reserve. So let's say you got cut really bad, but we taped it up really quick. The spleen would squeeze out a pint of blood just to get your blood pressure back up and make sure you had enough while we got you to the hospital. It's kind of cool. But it has nothing to do with digestion here.
Okay, so it's just chilling.
It's chill. It's just in the right location for this slide. Yeah. We do want you to know the liver is on the right side of your body, right upper quadrant. Right up here, right by your ribs. It can be a little bit under your ribs, especially if you have an enlarged liver. Some enlarged livers kind of push out against the rib even. I don't think any of you have that. I'm just saying it's up high. It's up high on your right-hand side. You should know where the liver is. That is something we're not going to come back and quiz you on like the duodenum or some valve. But it would be really good if you saw a picture of a body and you were like, that's the heart, that's the lungs, that's a liver, that kind of stuff. We want you to be able to do that, if that makes sense, right? And your spleen is on your left side, which, by the way, is why you never want to get stabbed in the left side there. Because if you get stabbed in the spleen, which was your emergency blood backup, it's not good. It's just not good. Don't do it. Yeah, oh, that's important. This bile, by the way, helps, again, like I already said, helps break up fatty acids. And the reason fat is important is not only do you make hormones out of fat, which are chemical messengers, so fat is a good thing, but you have fat-soluble vitamins too. There are vitamins that don't work in your body unless they're in fat. That's vitamins A, D, E, and K. By the way, fat-soluble vitamins are also the vitamins you're more likely to OD on. So water-soluble vitamins like vitamin C, in our society, most of us probably take 10,000 times the amount of vitamin C we need. It's probably in our food products, everything, but you just pee it out. You can't really OD on vitamin C. I don't think it can be done, but you can actually OD on vitamin A. And it doesn't usually happen in one sitting. It's not like, oh, I just took too much. What the problem is that the symptoms of vitamin A overdose are the same symptoms as the vitamin A deficiency. And so somebody starts taking vitamin A pills because they think they got a vitamin A deficiency, and then they keep having these symptoms and don't ask me what they are, I don't know. But so they take more and more vitamin A. It's fat soluble, and fat soluble vitamins don't go away as quickly, and so they can slowly overdose on them. It's a long process, but the mistake they really make is the symptoms of having too much vitamin A are the same symptoms as having too little vitamin A. Gallbladder, just to know that it stores the bile. So it does concentrate it too, but it's really to store bile. And bile's there to break down fat. That's it. And then finally your pancreas, which I already said, but it secretes enzymes that break down food. But that's really it. Good stuff. I don't even know if we get into the. You really don't need to know all the different types. You might need to know this one on here for your test, but you definitely don't need to know in your life the different types of enzymes that break down particular foods, unless you go into a different profession, not as a massage therapist. If you want to be a gastrointestinal specialist, then maybe. All right. I think that is a really good place to stop because that's almost the end. I think it is the end. And let's